Alright, we've seen how to graph a basic log graph in the previous video. And so now what I'm going to do is show you, or remind you rather, because I know you saw it, but I do think skills are important to kind of review. I'm going to show you how to graph a shifted log graph. So we're going to graph this, log base 2 of x minus 3. Alright, now there's many different approaches to graphing things like this. What I want you to start thinking about is transformations. In other words, this is a graph that the graph of a basic log graph that got shifted or transformed in a way that we can predict. So just keep in mind that log base 2 of x minus 3 is somewhat similar to log base 2 of x. It's that minus 3 that's the thing we have to pay attention to. So what I'm going to do is we did this in the last video, but I'm just going to jot it down again. I'm going to call our parent function log base 2 of x. It's like the simplest version of the shifted log graph. Okay, that's what we call it, the parent. It's like, yeah, there's all the bells and whistles, no minus 3. Okay, nothing fancy going on. So remember what we did was we wrote it as 2 to the y equals x, because that's that's how the definition of logs. And we made the table. So I'll just jot down the values in the table from the last video. And we had our picture. And we had the points 1, 1, I'm sorry, oops, I made that a 2. It was 2, 1, 1, 0, and 4, 2. And our graph looked like this. Okay, and I made the point that all log graphs have that basic shape. Those values 2 and 4 are going to change depending on your base, but there's your basic log graph. So what's that x minus 3, that minus 3 after the x, going to do to this parent graph here? Well, as you're going to see in future videos, and what you've already seen, I think, last year, is that minus 3, okay, that x minus 3, that has the effect of shifting the graph. Now, most students think it's just the graph left because they associate the negative with moving left. But it shifts the graph right 3 units. Okay, and I make kind of a big deal of this in the transformations video, which you'll see in a few days. For now, I think it's important just to remember that's going to shift the graph right 3 units. Okay, and that's important. It's an important observation. So here's how I like to do it. I would say, okay, some people do all these transformations right from the graph, but I always get confused. So I just transform from the table. So here's my new table. If I shift the graph right 3 units, if I'm going to shift my parent function right 3 units, that amounts to adding 3 to all my x values. So that's all I'm going to do. I'm going to add 3 to x values. Okay? Because again, shifting right 3 units means to add 3 to x values. So we'll just do that. So 3, 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5, and 4 plus 3 is 7. So there's my new x values. Nothing's happening to the y values, so you just copy them down. So there's a vertical asymptote now at 3 still, not still, the vertical asymptote is now at 3, 0, 1, 2. So the y values didn't change, so I don't need to copy them down. I don't need to change them. And my new graph is going to look like this. Well, the vertical asymptote is at 3. And I'm going to plot the point 4, 0. And I'm going to plot the point 5, 1. And 7, 2. and here's my shifted graph, right? If it was x plus 3, hopefully you understand that that would shift the graph left, and we would subtract 3 from the x values. But the important thing to notice is that I graphed this using this idea of transformations, right? I knew what my basic log function looked like, and I transformed it appropriately. Notice all the relationships stay the same, right? Like for instance, our vertical asymptote of our parent function was over here at the y-axis, and this point over here, the 0, the x-intercept, was 1 away from the vertical asymptote. If you go over here, the vertical asymptote is right here at 3, and the x-intercept is at 4, 1 away from the vertical asymptote. So with shifts, with horizontal shifts, that'll always happen. Those relationships stay the same. They've just moved their location. Okay?